Hello, good morning, and thank you, ma'am, for that kind introduction. I'm very glad to be here again to discuss with you. Actually, we launched this guideline if I'm not mistaken, last Saturday at the 22nd ASEP International Convention held at Novotel, and it was attended by 500 participants in person and about 100 online. So this is a bit of my outline, a bit of definition so that we will be on the same page of what a guideline is, what a standard is, and what a code is. And then some existing structural bamboo codes all over the world. And now that we are in the map of a structural guideline for bamboo. And then the proposed guidelines, and then what are the ways forward. So as a start, when we talk about a code, it is mandatory. It is legally enforceable. So that means when we design something, we follow the code because it talks about minimum design values. So the purpose actually is to make sure that we are safe and of course for public welfare. And you have here in the page some examples of the codes in the country, like the NSCP 2015. Currently, ASEP is vigorously working to update the 2015 NSCP, and hopefully this 2025 we will be able to publish the 8th edition of the NSCP, National Structural Code of the Philippines. So stay tuned, we will publish it this year. Of course, the IBC, the International Building Code, and the Philippine Electrical Code. Why did I put the PEC here? Because ASEP is also working with the IIEE in updating the wind zone map. Because that is what we are also developing for the NSCP. For a guideline, it's just a recommendation guideline. It's different from the code. The code is legally enforceable. So it gives some direction and advice on what to do. Of course, to improve quality, efficiency, or consistency. And you have here the Philippine Guidelines of Bamboo Design and Construction. Will be released in 2025, and hopefully we'll be able to launch it also here at TMSU. So we launch it through ASEP. Now we are launching it through Base Bahay. Thank you very much, Base Bahay. And we have here also the windows, and it's also a design and construction of bamboo scaffolds. Some examples. And finally, a manual. So we all know what a manual is, like an operations manual. It is detailed, it is instructional, and tells you how to perform something. So it's operational. So we have in organizations with operational manual, we have in a department with operational manual. Of course, it is not legally binding, but can be enforceable within an organization itself or a contract. An example of which I am very familiar with is the Manual for Earthquake Loads and Calculations. So we use this. And also the Manual for Wind Load Calculation. So because we know that the Philippines is a hazard-prone country, and so ASEP also developed this manual, especially to help our structural engineers. Okay, so for that comparison, you can see that the code again is what you must do legally. It's binding. And standards, what to do and what it must meet. And for a guideline, it's like what's advisable to do. And finally, for a manual, it's how to do it, how to do documents. So it gives you some instructions. You have here the main purpose, if it's binding or not, and a summary of what the document is. It's a bit small, but we know that I think the most complete country with bamboo code standards or guideline is Colombia. So we are actually really glad that Base Bahay together with Engineer Luis Lopez helped us develop this bamboo guideline. Because as you can see in the next slide, the complete bamboo building code actually is originated from from Colombia, and we are so grateful for that. But right now, what we are doing is we want to put the Philippines in the map, and we are starting with this standard. Actually, about 3 years ago, we started developing the part of the structural bamboo code. We were hoping it will be part of the NSCP 2025, Chapter 8 of NSCP, the structural bamboo code. But things are a bit, it takes time for this to develop. So what we can publish right now is the guideline. And hopefully, if it will not be published in 2025, the next edition of NSCP. So you can see here a comparison of where we are. And it is good that it's highlighted below. You can see that Nepal guidelines is actually complete. And we are following the international ISO 22156 in 2021, Nepal guidelines 2025, and the Philippine guidelines. And you can see the check marks for every column, and we are complete. Of course, this is not the document that is written in stone. This is a document that will evolve over time. With new research, with new findings, we can update it. But the best thing is we were able to produce it. And you can see, as what Dr. Michelle talked earlier, we have characterized the mechanical properties. We were part of this. DLSU started working with base by about, if I'm not mistaken, 8-9 years ago, with a few students going to base by and doing some mechanical characterization. And the derivation of design values, you have the beams, columns, connections, as what Dr. Michelle said, is very important. It's the devil is in the details, especially if the connection fails, then there's a high chance, high probability that your element or connection or beam to column will also fail. And also shear walls. Actually, one of my PhD students is doing work on shear wall testing. We've been working very hard to be able to do this load test as well as to characterize the damage and also to determine, hopefully, from the experimentation to the analytical model and see how this analytical model can predict the experimental results. So now, the proposed Philippine guidelines in bamboo design and construction, it is organized into 13 sections. 13 sections. You can see there the scope, some references, terms and definitions, symbols, basic requirements of design, member component and material properties, structural modeling of bamboo structures. Of course, flexural members, you have axial load carrying members, joints and splices, trusses, composite bamboo shear wall, fire resistance, harvesting and structural grading. 4 annexes. Harvesting and structural grading, chemical treatment, QC and maintenance, and then sample design problems. So it is organized into 13 sections, 4 annexes in 123 pages. So first is the scope. So we have to make sure that when we use the guidelines, we are within that scope limitation. So take note, this is the primary structural members are made of round bamboo. We are not talking here of bamboo that is put into concrete to make it a reinforced concrete. But we are talking here of round bamboo poles, where they're used as a shear wall system or simply the beam or column connections. And it is also used for 1 or 2-story residential house, commercial or institutional, and light industrial buildings not exceeding 9 meters, and I highlighted it here, for housing and 20 meters height for commercial 1-story buildings with mezzanine. And it specifies the requirements to mechanical resistance, serviceability, durability of bamboo structures. And also very important is we use allowable stress design. Because there are 2 philosophies of design, ASD and LRFD, the load and resistance factor design. So we are not yet moving to LRFD, we are into ASD when we design the structure, which is more conservative actually. Again, we, as showed earlier in the previous presentation, we are using 5 bamboo species. You have Bambusta blumiana, or the Hawaiian pilik. You have Dendrocalamus asper, or the giant bamboo, or boto. We have Bambusta merliana, which is bayo. Bambusta vulgaris, which is lunas. And the Guadua angustifolia, or the iron bamboo. These 5 species we have characterized and tested. So that's why and these are also the economically species that can be used for bamboo construction. Now, some exceptions. Structures made of engineered bamboo products such as glue lump, cross-laminated bamboo, oriented strand, or densified bamboo strand materials will not be part of this, or they are exempted from this guideline. Bamboo reinforced materials, where bamboo is the primary load-bearing constituent. So again, as I mentioned, concrete, and then you put bamboo as a reinforcing material like steel. Also, exception is that bamboo reinforced concrete, masonry, and soil, and scaffold structures constructed with bamboo. And the references that we use, you can see a lot of references, but I would like to highlight the reglamento, the regulation from Colombian construction for, if I'm not mistaken, seismic resistance. It's the same. Seismo resistant, it's almost the same. And of course, ISO, a lot of ISOs, bamboo constructional design or grading, and so on. So we use all of these references to be able to produce this kind of. So the basic design requirements, as I mentioned earlier, is that it is ASD, allowable stress design. The loads and load combination will be referred to, of course, NSEP, or its succeeding update, whether it's 2025, 2015, or 2020. The lateral force resisting system at this point in time will be 2, the braced frame and the composite bamboo shear wall. And a response modification factor, structural engineers will be very familiar with this, is 1.5 for braced frame and 2.0 for CBSW. Although when we have more results, we can actually refine this R value, this response modification factor. And 3 service classes, 1, 2, 3, we have here based on the equilibrium moisture content, less than 12%, less than 19%, and greater than 19%. Because moisture content in bamboo is very important. We have to make sure that it will not be beyond some value. Otherwise, we will introduce modification factors to reduce its strength. And susceptibility to splitting, redundancy, and durability. So you can see this in the guideline. For modeling of the bamboo structure, take note it is linear elastic. We are not moving towards non-linear response of the structure. We are using the mean of the modulus of elasticity, 0.75 confidence interval, and the density, also the mean, for both E and density. They satisfy Bernoulli beam theory, but this is engineering mechanics. If you are into engineering, plane sections remain plane before and after bending. This is an assumption. And we model it as hollow tubes, of course, because bamboo can, the thickness can, the diameter can also taper a bit. So we use the smallest dimension to be conservative. And multiple column member is modeled as a single bamboo, multiplied by the total number of columns bundled together. Unless we can verify composite action of bamboo as a group. Otherwise, we just simply multiply by the number of columns. We also assume that the joints are pinned. Pin, that means in structural engineering, that means it cannot resist moment, it can just rotate. It's a pin connection. Otherwise, if it's substantiated by experimental design, then we can use some other type of fixity, like if it's fixed. In this case, we can assume it will be pin. Also, the joint stiffness is included, and deformation or slip of the judge shall be accounted for in the analysis. And also, these members are not subjected to torsion. We have not done yet, I think, torsion as a load for one. We have compression, tension, parallel and perpendicular to the fiber, but not yet torsion. And well, period of bamboo structure, I don't think it's this is too significant because it's just a low-story building. Period would mean the response of the structure with respect, especially with respect to lateral ground motion. When the period of your structure is the same as the period of your forcing function, that means you will have resonance, and therefore displacement will be large. So I don't think this will be a big factor. But if you want, you can calculate the period of the bamboo structure. So this was seen earlier, the characteristic properties that we have been doing, not only in Dela University, but we also have other universities already joining into this research on characterizing the mechanical properties of bamboo, like compression parallel to the fibers, tension parallel to the fibers, bending strength parallel to the fibers, density, shear strength, tension, shear strength perpendicular, bending strength perpendicular to fibers, and modulus of elasticity. And I remember during the pandemic, one of my students was doing research at Base Bahay alone. He had an entire lab for himself doing bending tests at Base Bahay. So it was a good time. Now we have to schedule our testing because a lot of universities now are also doing tests, whether it's shear wall, whether it's characterization, and so on. You can see this table using all of this redundancy factor, material factor of safety, low duration factor. It's like timber, there's a low duration factor for modulus, and of course elevated service temperature factor. All of these factors, you input that into the equation, you get some values for your design. And also the allowable member capacity, axial capacity, that's for especially for compressive elements like columns, and for members that are stressed in tension, like part of the truss, it can be compression or tension. Flexural capacity, when you have a member that is flexed, there's bending, and shear, when there's a load that is parallel to the plane of action, and of course a possible combined axial and bending, especially for columns. You have compression as well as bending. So you have all of these formulas that you can use to be able to design. This has been shown earlier, the composite bamboo shear wall. We have two types, the single cladding system and the double cladding system. So one cladding and then double cladding. And yeah, a lot of studies have been doing now at Base Bahay to be able to characterize the performance of these shear walls. And connections, different types of connections. P connection, T connection, and Q connection. Because it depends on how you're going to connect two elements together, two or more elements together. So it depends on if it is just a column to beam or in a simple truss, how you're going to connect a diagonal member, for example, to the bottom chord and the top chord. And also we have in the guidelines a bamboo grading. So if you notice in the left part portion, these are damaged, defective, and may not be used for structural construction. And you can see in the middle, high quality graded bamboo parts for use. So you're certain, you're confident that these will perform when needed, especially for strong winds or strong typhoons or earthquakes. And there's also a treatment process. I think some of you went to Batangas yesterday and have seen the treatment process of how bamboo should be treated so that when it is used for structural application, it is ensured that it will last, not only for a short period of time, but for longer periods of time. This is the treatment process. So from inspection until you rack it for final dry of treated poles. All of the bamboos that we use for tests are being treated. So we are sure that they pass this rigorous quality control. So step one, from inspection to pre-cleaning, to punching on the nose, to washing, inspection of wash poles, treatment, soaking in a treatment solution to remove the starch, and then to remove the excess solution, finally drying, whether it's air dried or sun dried, and then for storing. So 9-step treatment process. We will also know that bamboo or even timber has little fire resistance. But we can improve it by using some protection or coating, but it can be expensive. So therefore, if we expose bamboo to fire, then there's a high chance of course it will fail. So therefore, what we can do is to put some say some cement or mortar to be able to protect the bamboo, especially when it is subjected to fire. Sometimes you cannot avoid the fire within, whichever it will start with, from within or from outside. So protecting the bamboo is also important, especially for fire resistance. But we refer to applicable national standards for testing fire resistance for bamboo and assemblies. So we have, as I mentioned, 4 annexes: harvesting, structural grading, chemical treatment, quality control and maintenance, and sample design problems. Usually in a manual, on a guideline, you can see some example problems to guide, especially new structural civil engineers to do that. And we are continuing to do it, not only for the standard, but hopefully for the code. And lastly, hopefully we will be like Bamboost. The higher we grow, the deeper we go. Thank you very much, and have a good day.
Thank you very much.